Hi, welcome back to LeetCode. In this we discuss LeetCode problem 3418. Maximum amount of money robot can earn. So you are given an m cross n grid. A robot starts at the top left counter corner of the grid 0, 0 and wants to reach at the bottom right, means m minus 1, n minus 1. The robot can move either right or down at any point in time. So the grid contains a value coins I comma j in each cell. So cell value can be greater than equals to 0 or less than 0. So if it is greater than equals to 0, positive, so the robot gains that many coins, so it will be added to his profit. Else if it is less than 0, then he will lose that many actually coins, right? Encounters a robber and the robber steals the absolute value of coins I comma j coins. So the robot has a special ability to neutralize robbers in at most 2 cells in each path. So if he can do that maximum 2 times in this path, so what is the maximum coin actually he can earn? So we have to return this maximum coin, maximum profit. So this is a recursion, simply recursion. You can think about it like in its currently we are suppose in cell I comma j. So I can go to the actually right or I can go to the down. So from down, suppose I got x number of coins, and from right actually I got y number of coins. So I will try to take the maximum value, right? What are the maximum value that I actually return? So return the maximum value of x comma y. So I'll choose that route and take the maximum, right? This is, so in this way we will go to the actually index 0, 0 I'll reach. So this is a recursive approach. So what is the base case? So base case is that when we reach, so for this recursion, so what is the base case? Base case will be when we reach I is equal to m minus 1 and j is equal to n minus 1. So this is the bottom right. We have started from 0, 0. When you reach this cell, like I will be at the m minus 1 and j will be at the n minus 1. That time we reach the bottom right cell. Now what actually we have to return? We have to return that coins of I comma j. But what is the interesting fact here? That we have to check that they have mentioned that k is equal to 2. K is equal to 2 means what? Initially it represents that we can call this the neutralize operation maximum 2 times initially. So we'll check that is there any operation still left. Okay, so I'll check that the current number of coins in the current cell is negative. Then I will check that okay, I can neutralize or not. If I can neutralize this, then I will return 0, else I have to return coins I comma j. So this is the base case, correct? If I am able to neutralize this, that time return 0, else I have to return coin, whatever the coin actually present, that negative or positive, any I have to return that, right? So this is the base case. Now what are the other cases it possible? So we are in intermediate cell, any intermediate cell, suppose I comma j. So I'll check that if our current cell is positive, it may be possible. If it is positive, then what I have to do? I will go to the right. Then I am calling this helper function again when I am passing this I comma j plus 1 and passing the k initialized with 2 because it represents the number of operations it is still left to neutralize, right? And similarly I will call this helper function again when I am going down, right? I plus 1 comma j. So I will get 2 value. I will got 2 value right and down. So I'll choose whatever the current coin actually I have in the current cell, that will be always added, and the maximum value from the right shift or the down shift I'll choose, and I'll add this, and I'll return the ultimate value. In the same situation, it may be possible that the current number of coins in the current cell is negative. Okay, and I can skip also, right? I do not want to neutralize the current cell. I can want to neutralize in the future. It may be possible that I need to neutralize in the future twice. Then I will actually optimize more, right? So that's why I can actually skip that. So that time also I can actually call similar operation will happen, right? This is clear. When it is positive, else it is negative, and I want to skip this neutralize operation here in this current cell. that time also it will be same. Now case 2 will be what? The current number of coins in the current cell is negative, but I want to neutralize in the current cell. So that time I have to check that the k greater than 0 or not. If it is 0, that means I can neutralize this in the current cell. That time what I will do, I will just call the right and the down, both the operation what I am passing, again calling this helper function recursively, passing the right cell index is I comma j plus 1, and I am passing here k minus 1. Why k minus 1? Because I am using one neutralize operation here in the current cell, that's why this will decrease by 1. Similarly for the down also, I am the down cell index of the down cell will be I plus 1 comma j, and I am decreasing the k value as minus 1, k minus 1. Got it? Now what will be the maximum coin actually I will got two value, right? If I go to the right and if I neutralize in the current cell, then what will the maximum number of coin actually I can take, and from the down also similar. So I'll choose whatever the maximum value. So what is the maximum value from the case 1? When I skip this, when I skip to neutralize in the current cell, then what is the maximum number of coin actually I can achieve? And the if I go neutralize here and if I go to the right side, then what will be the maximum number of coin actually I can achieve from the right, and similarly from the down. Got it? And what is the maximum value? I have to return this. Got it? So this is the three cases. First is the base cases. Base cases is what? Like when you reach the bottom right, then I will check that okay, if the current number of if the current coins in the current cell is negative or not. If it is negative, then I can check that I can neutralize or not, right? What will check? I will check that k greater than 0 or not. So k represent here actually the number of operation neutralize operations still left. So if I able to neutralize this, then I will return 0, because I have to get the maximum number of, I have to maximize the number of profit. And else what I have to return, whatever the number of coin it is present, that I have to return, because there is no option. If it's positive, then we don't need to do the operation. But if it's negative, but we are not able to, there is no option left to neutralize this, then I have to return the number of coins, that is minus 10, minus 2, anything that I have to return. And case 1 is when the current coins in the current cell is positive, then what I have to do the same thing. I will go to the right and take I'll return get what are the maximum number of coins actually can get from the right side and from the down side, and I'll choose the maximum value out of these two. Okay, negative, for the negative also it is possible, like I can skip this neutralize operation in the current cell, then I can also get the maximum value. So that's why if it is negative and it is skip, I want to skip this neutralize operation here, then also I will get the same value. And case 2 is if the current coins in the current cell is negative, and also I want to neutralize in the current cell, then I will call this and I am decrease the k minus 1. Got it? So this is the recursive approach. So how can I actually optimize this? I am using DP here. How I can use? So there are three things: I, J, K. So Ij represent the current index, cell index, and K represent the number of operations still left, right? So here actually, how can I actually use memoization in the recursion? I will check that which variable state is changing. So for this, suppose first explain this, then I actually explain the memoization how I have used here. So first of all, I have used calling this helper function. I am starting index is 0, 0, and 2 operation is still left, and I am passing the coin. So what I will do, I have base case. This is the base case. Base case is what? I have reached the m minus 1 and j also n minus 1. Okay, I will check that can actually neutralize or not. So if k greater than 0 and the current number of coins in the current cell is less than 0, then I return 0. Else I will return the number of coins that is present, that I will return. So this is the base case. This is clear. Now what I will do, this is the case 1. Case 1 is what? If number of coins in the current cell is positive, or if the current number of coins in the current cell is negative, and I want to skip the neutralize operation here, then what will happen? I will go to the right cell with I comma j plus 1, and number of k will be same because I am not neutralizing here, and similarly for down. So I will choose the maximum value of from right or down, and I will add this into the maximum coins. Now this is for the case 2. Case 2 is what? It is negative, number of coins in the current cell is negative, and I want to neutralize here. So I have to check that I can neutralize or not. So if the current number of coins in the current cell is less than 0 and k greater than 0, then I actually neutralize this. So I'll go to the right side and the down cell both. So I'll export both the cell again with the configuration as k minus 1, because I have called I have neutralized this So that time I will export all the maximum coins, and I will take the maximum out of this 3 variable. Maximum coins is from the case 1 and right and down is from the case 2 when I am utilizing in the current cell. So I will return this maximum coins from here. Now how can I use the memorization here? So I will take a DP vector where there is 3D DP vector, one for the I, another for the j, and this is for k. So here actually 3 variable changing I, j, k, because coin is still constant because this is from the input. So that's why I'll take a 3DP vector or 3D vector, and the initial size is 501, 501, 501, 3. Why? K value can be 0, 1, 2. So that's why I need 3. Okay, and I am initialize this with -1, but this DP vector. And what I have to do here extra, that I will check that if it is out of bound, then return -infinity. This path is not possible, that's why -infinity. And for DP, what I have to extra use here, I'll check that this state I, j, k have already explored or not. How would you know that this explored or not? If it is -1, -1 means I have not explored yet. If it is not -1 means I have already explored this state. So that's why whatever the value actually I have, return that directly. I do not need to do this operation. Okay, and at the end what to do? For suppose I have not explored this state I, j, k, first time I am coming for this state. So what I will do, before returning, I will store this into this DP vector, and then I will return. Got it? These cases and the how actually use the recursion and the DP, it is clear. If any doubt, any confusion, you just comment on that. If any suggestion, you can also comment on that. Please, if you are not yet subscribed, please subscribe the channel. Thank you.